Hey everyone, and welcome to this explainer. Today, we're cracking open the Interview Coach Playbook Engineering Edition. And look, our goal here is simple, but it is absolutely game-changing. We are going to completely transform you from a candidate who just kind of recites textbook definitions into a practical, field-ready problem solver in the eyes of top recruiters. So if you want to absolutely crush your next engineering interview, you are exactly where you need to be. Let's get into it.
Think about this for a second. Are you answering interview questions like a student who just memorized a book or like a total pro who actually solves real problems on site? I know, it's a bit of a provocative question, but honestly, it's the defining factor between getting a polite, generic rejection email and securing a massive job offer. In this fast-paced masterclass, we're going to bridge your academic knowledge with that gritty on-site reality, showing you exactly how to instantly upgrade your answers.
Okay, before we get into the heavy technical stuff, we need a game plan. Enter the STAR method: situation, task, action, and result. When you get hit with behavioral or technical questions, framing your response with this universal tool is a massive power move. It proves you have that pro-engineer mindset. It tells them you don't just know the theory, you actually know how to assess a situation, figure out the task, execute a really decisive action, and deliver a tangible result. Keep this framework in your back pocket as we run through today's scenarios. All right, Section 2, Mastering Concrete Placement. Let's dive right into a classic heavy-duty technical interview scenario. The interviewer asks, what is the difference between segregation and bleeding? So here's where our contextual answer strategy really shines. The textbook answer, it just gives the dictionary definition. It says segregation is the separation of ingredients and bleeding is water rising to the surface. Yawn. It's boring and literally everyone says it. But the pro engineer, they give an on-site response. They say something like, a slump test measures workability, sure, but if bleeding occurs due to overcompaction, here is exactly how I adjust the mix and my vibrating protocol. Boom. That immediately proves to the recruiter that you're a practical problem solver who takes charge when a badge is compromised before it even hits the slab. And you've got to have the hard data to back that up, right? Segregation is often caused by improper mixing or, say, dropping aggregate from a height greater than 1.5 meters, which obviously makes the structure weak and porous. Bleeding, on the flip side, is actually a form of segregation. It happens when the solid constituents can't hold the mixing water, often because of overcompaction. By citing these exact causes and explaining your remedies, like controlling drop heights and making sure you don't overvibrate, you totally validate your field expertise. Moving on to Section 3, Earthwork Estimation Risks. This focuses on what is hands down the most volatile phase of project budgeting. How do you calculate earthwork volumes and avoid catastrophic budget overruns? Let's pit the academic answer against the field-tested one again. The student says, oh, I'd use the grid method for flat sites or the cross-section method, which is true, but it's just not enough. The pro engineer says, I use those methods, absolutely, but I know soil is highly dynamic. I strictly track the swell and shrinkage between bank, loose, and compacted states, because if I don't, our profit margins will literally vanish. This is huge. It highlights the massive financial risk of treating dirt like some static variable on a spreadsheet. Since earthwork is usually bid on a lump sum basis, if you underestimate it, the contractor just eats that loss. No one wants that. To put this into perspective, the sheer scale of this risk is just massive. Think about the primary states of soil. When you excavate natural undisturbed earth, that's your bank state, you introduce air. For materials like clay, shifting it into a loose state for hauling can cause a wild 58% volume swell. Imagine budgeting for 1,000 dump trucks based on your neat 2D grading plan, only to get out in the field and realize the soil swelled so much you actually need 1,600 trucks. There goes your margin. Showing an interviewer that you understand the material actually dictates the math, that's a massive competitive advantage. All right, Section 4, Ensuring Structural Integrity. Let's tackle a huge, often invisible threat on job sites: construction fraud and structural failure. The question is, how do you verify steel reinforcement upon delivery? There is a world of difference between knowing basic tension theory and having hypervigilant site awareness. The textbook mentions that starter bars connecting to columns need a lap splice overlapping by 20 to 40 times the bar diameter, which is good to know, but the pro engineer points out that on a chaotic site, visually identical steel bars can actually be part of a deliberate scam. They'll say suppliers pull bait-and switches, sneaking in standard FE500 instead of the high ductility earthquake-resistant FE550 SD we specified. Here is my exact protocol to reject fraudulent material. This shows you know how to protect a building's seismic capacity from an invisible but literal threat. So let's actually walk through a strict 4-step verification protocol you can virtually hand to the recruiter. 1. Physically verify the brand engraved embossed right on the steel bars. 2. Demand the test certificates and match those heat numbers straight to the bundle tags. 3. Pull out a tape measure and physically verify those lap lengths against the drawings. And 4. Confirm your cover blocks are perfectly placed. Executing these steps catches substandard materials dead in their tracks, stopping brittle collapses before a single drop of concrete is ever poured. Next up, Section 5, handling construction disputes. Because let's be real, no matter how perfect your site is, conflicts over quality, schedules, or conditions are totally inevitable. How do you resolve a conflict over defective work or delays? The textbook might tell you to just follow the contract's legal clause and escalate straight to litigation. But the pro engineer knows litigation is a nightmare. It's expensive, public, and incredibly slow. Their on-site response is way better. They say, I immediately document the facts, the impacts, and all supporting evidence, objectively, without any public blame. I rely on our ethical codes to propose a clear call to action. They control the narrative early, managing the risk directly while keeping the project moving. And honestly, this strategy hits the nail right on the head when it comes to the National Society of Professional Engineers Code of Ethics, which explicitly states engineers shall issue public statements only in an objective and truthful manner. When you're in the middle of a dispute, you do not deal in assumptions or blame. You document the facts, and then you couple that objective documentation with a clear call to action, telling everyone exactly what needs to happen next. Tying your management style directly to core engineering ethics builds ultimate credibility. It's just smart business. Okay, we've reached the ultimate pro tip. When the interview is wrapping up and they inevitably ask, do you have any questions for us? Please do not just sit there in silence. Flip the script. Ask them high-level operational questions. Ask about their specific quality control standards on site. Ask what project management software they're running right now. Are they using PlanSwift or maybe MS Project to track critical paths? Asking these things makes you sound like a high-level peer who is already strategizing about how to integrate into their daily operations. It's an absolutely killer way to close the meeting. So are you ready to stop reciting from the textbook and start dominating the job site? Today, we've stripped away the fluff to look at the raw mechanics of presenting yourself as a real problem-solving professional. Remember, recruiters aren't looking for a walking dictionary. They want someone who understands the financial risks, the ethical obligations, and the gritty physical realities of the field. Take these tools, use the STAR method, deliver those contextual on-site responses, and go demand exactly what you are worth at your next interview.